Good day everyone, today we're going to be talking about rational inequalities, but before proceeding with the topic, let me introduce to you my members, researchers Bless Allen and Paulette Malaran, scriptwriters Alexa Froilat and Don Johnson Gigayuma, video editors Gabis Cabido, and let me introduce myself. I am Alfred A. Madrinin, your presenter for today. What is a rational inequality? A rational inequality is an inequality that contains a rational equation. Inequalities such as greater than 1, lesser than 4, greater than or equal to x, and lesser than or equal to are rational inequalities as they contain a rational expression. It originates in the 5th century BC with the Greek philosopher and mathematician Pythagoras of Samos, the man who envisaged what would eventually become the modern science of physics and who is first associated numbers with the male mind. So, how do you know if it's a rational inequality? A rational inequality is an inequality which contains a rational expression. The trick is to be dealing with rational inequalities is to always work with zero on one side of the inequality. Rewrite the problem if necessary to obtain a zero on one side. Take note, when dealing with inequalities, if we multiply both sides by a negative number, we must switch the direction of the inequality symbol. Since the denominator contains a variable, we don't know if it's a positive or negative. So, we don't know if we need to switch the direction of this symbol. Thus, the rational inequalities, we can't eliminate the denominators by multiplying both sides of the expression containing a variable. So, the steps in solving rational inequalities are: Step 1. Write the inequality as one quotient on the left and 0 on the right. Step 2. Determine the critical points, the points where the rational expression will be 0 and or undefined. Step 3. Use the critical points to divide the number line into intervals. Step 4. Test a value in each interval. Above the number line shows the sign of each factor of the numerator and denominator. In each interval below the number line, show the sign of the quotient. Step 5. Determine the intervals where the inequality is correct. Write the solution in the interval notation. We must also consider how we'll know if the answer is undefined. Determine the critical points. Point where the rational inequalities will be 0 or undefined. Rational expressions will be 0 when the numerator is 0. Rational expressions will be undefined when the denominator is 0, since x minus 1 equals 0 when x is equal to 1, then 1 is a critical point. Now, what is the solution to this rational inequality? To solve a rational inequality, you first find the zeros from the numerator and find the undefined points from the denominator. You use these zeros and undefined points to divide the number lines into intervals. Then you find the sign of the rational on each interval. What is the 4 rational inequality? The 4 rational inequalities are greater than, lesser than, greater is or equal to, lesser than or equal to. If there is an equal sign, then it is rather a rational equality. How do you simplify an inequality? To simplify an inequality, we want to isolate the variable on one side of the inequality sign. To accomplish this, remember to do the reverse operation to move the numbers from one side to the other. Let us proceed with the examples. In the first example, solve and write the solution. Interval notation: 4x over x minus 6 is lesser than 1. Now, we have to subtract 1 to get 0 on the right. Then we rewrite 1 as a fraction using the LCD. Next, subtract the numerators and place the difference over the common denominator. Simplify things to make things easier. Now we factor the numerator to show all factors. So we find the critical points. The quotient will be 0 when the numerator is 0. The quotient will be undefined when the denominator is 0. X plus 2 equals 0 turns to x equals negative 2. X minus 6 equals 0 turns to x equals 6. Now we use the critical points to divide the number line into intervals. There's a value in each interval. We just simply substitute the x with the values. Take note that above the number line, show the sign of each factors of the rational expression in each interval, while below the number line, show the sign of the quotient. Determine the intervals where the inequality is correct. We want the quotient to be negative, so the solution includes the points between -2 and +6. Since the inequality is strictly less than, the endpoints are not included. We write the solution in interval notation as -2 and +6. This is the number line for a clearer look. Let us proceed with example number 2. 3x minus 10 over x minus 4 is greater than 2. Let us first simplify. But you cannot multiply x minus 4 because x minus 4 could be positive or negative. We don't know if we should change the direction of the inequality or not. Instead, bring 2 to the left, then multiply 2 by x minus 4 and x minus 4. Now we find the common denominator. Let's bring it all together. Now, we just first simplify. Second, let's find the points of interest. At x equals 2, we have 0 over x minus 4 is greater than 0, which is equal to 0 point or a root. At x equals 4, we have x minus 2 over 0, which is greater than 0, which is undefined. Third, do the test points to see what it does in between. At x equals 0, x minus 2 equals -2, which is negative. At x minus 4 equals -4, which is negative. So, x minus 2 over x minus 4 must be positive. So, we can also do the same with x minus 3 and x minus 5, and we end up with these results. Now, let us proceed with the example number 3. Before we get into solving these, we need to point out that don't solve in the same way that we've solved equations that contain rational expressions. With the equations, the first thing that we always did was clear out the denominators by multiplying with the least common denominator. That won't work with these. However, since we don't know the value of x, we can't multiply both sides with anything that contains an x. Recall that if we multiply both sides of an inequality by a negative number, we will need to switch the direction of the inequality. However, since we don't know the value of x, we don't know if the denominator is positive or negative, and so we won't know if we need to switch the direction of inequality or not. In fact, to make matters worse, the denominator will be both positive and negative for the value of x in the solution, and so that will create real problems. So, we need to leave the rational expression in the inequality. Now, the basic process here is the same with the polynomial inequalities. The first step is to get 0 on one side, and the other side is a single rational inequality. This has already been done for us here. Then, the next step is to factor the numerator and denominator as much as possible. The next step after that is to determine where both the numerator and denominator are 0. In this case, these values are, the numerator is x equals -1, and the denominator is x equals +5. Now we need to find these numbers for a couple of reasons. First, just like polynomial inequalities, these are the only numbers where rational expressions may change the sign. So, we'll build a number line using these points to define ranges out of which to pick our test points, just like we associated with polynomial inequalities. There is, however, a reason for needing the value of x that makes the denominator 0. However, no matter what else is going on here, we do have a rational expression, and that means that we need to avoid division by 0, and knowing where the denominator is, 0, will be giving us the value of x to avoid for this. Here is the number line for inequality. So we need regions to make the rational expression negative. That means the middle region, also since we've got an or equal to part in the inequality, we also need to include where the inequality is 0. So this means we include x equals -1, and notice that we will also avoid x equals +5, since that gives division by 0. Above all, the solution for this inequality is, first, our inequality must be 0, then we transpose 1. Simplify the left side of our inequality, then we find the LCD. Our LCD is x plus 3. Just copy x plus 3. X plus 3 divided by x plus 3 is equal to 1. Then 1x, 2x plus 10. Now we need to find the denominator of 7 is 1. X plus 3 divided by -1, that is equal to x plus 3. So in this case, we need to simplify the numerator. So copy 2x plus 10, then -1x, x equals -x, then simplified version of this is -1x, parentheses, x plus 3, parentheses, that is equivalent to -3. We need to combine 2x minus x. Next, 10 minus 3, that is equal to +7. Find the zeros, and then the zeros are x equals to -7 and x equals to -3. Rational inequality. We need to combine 2x minus x. Next, 10 minus 3, that is equivalent to +7. Find our zeros. X plus 7 equals 0 is x equals -7. X plus 3 equals 0 is equivalent to x equals -3. Rational inequality. 3x minus 15 over x is less than or equal to 5. Our first step is to find the inequality and must make it equal to 0. Transpose 5 to the left, use the addition property of the inequality. Then find the LCD. Our LCD is x, so divide that by x, and that is equal to 1. Multiply 3x minus 15, that will give us just a copy because it is already equal to x. Now, divide x by 1, since we already have 1 here. X minus 5, then x divided by 1x, that will become x squared. Simplify our numerator, arrange them first by descending order so that it will be x squared. 3x minus 5x, so it will become 2x minus 15 all over x. Find the zeros. Our x minus 5 equals 0 will become x equals 5. X plus 3 equals 0 will become x equals -3.